and then we're going to move on to use substitution. Yeah? I really don't want you to take it right now because I don't want you to not understand the notes. So how about you do it tomorrow? So that way you're not missing day one of a new thing. Okay?
It's a new thing?
Yes, and then you too, Jenny. It's a new thing, yeah. Okay, but average value theorem's not really. Okay, do you remember how to find average value to begin with?
Yeah, 1 over b minus a.
Okay, good. Average value is 1 over b minus a, integral a to b, f of x dx. Okay, so there is a theorem, okay, that says that whatever the average value is, there has to be an x value where that was the y value. Okay, so we're only going to do 2 examples of this. We're going to do them with a calculator to keep them really short, but I want you to have the theorem in your notes so that you have it written out. So the first thing is that this theorem only applies if f of x, a continuous and integratable function. Okay, for f of x, a continuous and integratable function, there must exist, remember the little backwards e, okay, and x equals c within a to b. It can be an endpoint for this theorem, such that f of c is equal to that average. Okay? So write that down, and then we're going to do one example of that. Find value, bless you, of c that satisfies. Hey. Thanks. Y equals 1/3 x to the 5 plus 2 on 1, 2, 6. Okay, so go ahead and just write it down first. We're going to do the whole thing in the calculator, which should make it not take very long. Okay, so the first thing that you need to do is check if it's continuous. Okay, so think about 1/3 x to the 5th. Okay, this is a polynomial. Are polynomials going to be continuous? Okay, yes. So we automatically know this is a continuous function because it's a polynomial. So I'm going to put here polynomial, therefore continuous and integratable. Okay, and then a little check. Okay? So if it's a continuous function, then I'm going to find the average value, okay, which is 1 over b minus a, which is 6 minus 1, integral 1 to 6, and then of my function, which is 1/3 x5 plus 2 dx. Okay, so that's going to tell me the average value of the function on that interval. Now, like I said, I'm just doing it in here. Okay, so I would do 1 divided by 6 minus 1. Okay, then math 9, 1 to 6. And then my function is 1/3 x to the 5 plus 2 dx. Everybody good with that? We already know how to type that in. Okay, so it comes out to be 520.3888. Write that down. Okay, 520.3888. Now remember, you can round at the 4th decimal if you want to, but you just can truncate it as well, as long as you go to 4. Okay, so what this means is that is the average y value on the interval from 1 to 6. Okay, so we are now going to look at the graph of that, and hopefully that will make sense. So first question I have for you is, when I'm trying to find my C, where does my C have to be between? Look at your definition right here. C has to be within A to B. So when I do my graph, I'm not going to look at a whole big window. I really only care about 1 to 6. So in my y equals, I'm going to type it in. So it's 1/3 x to the 5 plus 2. Okay, and then I'm going to go to my window. I'm going to make it 1 to 6. Now, for my y value, what did it come out to be? 520. Now think about it. If that's the average, are there going to be numbers bigger than 520 and less than 520? Yes. So I'm going to come into my y min. I'm going to make it 0. I'm going to make my max like 1,000. If the average is 500, I know the max is going to be higher than that, right? So let's look at the graph. Okay, there's your cubic. Oh wait, I forgot to type in the second one. Then I should also type in the average, which was 520.3888. Okay, duh. There it is. Okay, now, does it make sense that that's the average? Half of the graph is below it, half of the graph is above it. Now, I can't see this part of the graph, but that perfectly cuts my height in half. So how do I know when my function equals that average value? What do I look for? Intersection. So second trace, intersect, enter, enter, enter. Okay, it happens at 4.3486. Okay, now we're going to sketch that in your notes so that you have a picture of it. Okay? So right here, our function looks like that. Our average value was here. Okay, 520.3888. And then this would be the C value that I care about, because that's where my graph actually equaled that average. Okay? So my C came out to be, like I said, 4.3486. And then remember that C has to be on the interval, which is from 1 to 6 is the end. So your C has to be between those same two x values that you already had. Okay, and then I have half the graph above, half the graph below, but that's because this is the average. Okay, and so that should at least sort of make sense why that came out to be the average. Okay? Alright, we're going to do one more like that real quick before we get into our super new stuff. So I'm going to put find value of C to satisfy AVT for average value theorem. Y equals sine 6 sine x plus 1 on, we'll do 1 to 4. Okay, so first question, think about the graph of sine x. It goes like this. Up, down, up, down, up, down, up, down. Is it continuous? Yes. What about the 6? What does that do? Yeah, it makes it, instead of going 1 to 1, 1 to 1, it goes 6 to 6. Now, what does the plus 1 do? Shifts the whole graph up. So instead of going from 6 to negative 6, it goes from 7 to negative 5, and then 7 to negative 5. Okay? So the first thing that I'm going to do is I'm going to find my average value. 1 over 4 minus 1, integral 1 to 4. My function was 6 sine x plus 1 dx. And I'm going to calculate what that average value is on that interval. Okay? So let me type that in here. We're doing 6 sine x plus 1. Okay, we're doing 1 over 4 minus 1, math 9, 1 to 4. And then alpha trace y1, and then dx. So it should look just like that. Okay, my average value came out to 3.3878. 3.3878. That's the average. Okay, what do I do next? I want to look at a graph, and then find where my equation equals that number. So in my y equals, I'm going to go down to my y2, I'm going to type in the average, and then I'm going to look for where they cross. Now, let's check our window before I push graph and have to wait forever to fix it. What should my x's be? What interval? 1 to 4. And what should my y's be if sine can only go from -5 to 7? -5 to 7. Yeah. I'm going to just go -10 to 10, but you get the idea. I just want to be able to see the whole thing, right? So there's my graph. Notice half of the graph is where? Above. Half of the graph is below. Why? Because this is the average. How do I know where the average happens? Second trace, option 5, enter, enter, enter. Okay, and it's 2.7322. Okay? Now notice that because of the shape of this graph, it's not hitting perfectly in between 1 and 4 every time. So you can't just pick the middle value. You need to actually find the average, graph it, and then look for where they cross. Okay? So a little picture here. Okay, your graph went like that. Your average value is here. That was the point. That was your C. And then your C value is equal to 2.7322. Now, quick question. Let's say that I forgot to change my window and I left it at 0 to 10. How many times is sine going to hit that average? Literally for forever. It will keep hitting it over and over and over again. But I have to pick the one that happens between where? 1 and 4. So if you graph the whole thing, I know that I want this one because that's between the values of 1 and 4. Even if it happens more than once, I only care about the one that happens on my interval. Does that make sense? Okay, cool. Okay, so now I want you to retitle a new thing in your notes. You're going to learn how to do U substitution. Okay? U substitution is what it's called. Like the letter U. You don't need a calculator now. Sure. Okay, but that's your title. U substitution. Yep. Okay, so here's what U substitution is. I'm going to make a yes-no list for you. And then I want you to try to figure out what you think U substitution is. So this is going to be no U sub. This is going to be needs U sub. Okay? If I wanted to take the integral of 5 sine x dx, I do not need U sub. If I want to do the integral of sine 5x, now I need U sub. Okay, I'm going to give you 2 more examples to look at. Next one. If I have 3x squared plus 1 dx, I do not need U sub. But if I have 3x plus 1 squared dx, I do need U sub. Okay? One more example left. If I have 4e to the x, I do not need U sub. But if I have e to the 4x, I do need U sub. Okay, look at the list. What do you notice is different about the right side over here? Okay, the numbers with the x. Okay, if I was taking derivatives, would these need chain rule? The left side. No. The right side, would these need chain rule? Okay, yes. So if it would have needed chain rule, then it will need U sub when you undo the derivative. Okay? So I'm going to put here, these need chain rule for the derivative, and they need u sub for the antiderivative. Okay, so what you should know is that u substitution is the chain rule of integrals. Okay. So what we're going to do is we are going to work 3 examples in a row. I'm going to show you the steps, and then we're going to write them out after we've done 3. Okay, just to make sure that you kind of understand a few examples so that we can write out the steps. Okay? So you ready for number 1? Okay, and I need you all 100% paying attention for the first 3. Otherwise, we're going to end up having to crawl through these really slow. Okay, so number 1 is going to be easy. It's going to be the cosine of 4x dx. Okay, and then like I said, the first example is going to be super weird. Then the second one will make a little bit more sense. Then by the third one, you should have an idea of how to do it. So the first thing that you're going to do is you're going to pick u. U is going to be what your u would have been in chain rule. So my u is going to be 4x, okay, which is inside of cosine. After I choose the u, I'm going to take the derivative, which is du dx. Now, what does that stand for? That's the derivative of u with respect to x. So what's the derivative of 4x? 4. Okay, the next thing that you're going to do is you are going to take this dx off the bottom, and you're going to multiply it on both sides to where now it's on the 4 side. So I had du dx. I multiplied it across to the 4 side. So now it's a 4 dx. Everybody good to there? So I have this. du equals 4 dx. My next step is going to be to get dx by itself, which requires me to divide by 4. Everybody good with that? So here's what I have now. dx equals du over 4. I want you to circle u equals 4x, dx equals du over 4. Using those 2 substitutions, I'm going to change my integral from x stuff to u stuff. So here's what it's going to look like. I'm going to take the integral of cosine, but instead of a 4x, what am I going to put in its place? Well, now it's just, remember, u is 4x, so now it's just u. And then instead of a dx, what is dx equal to now? Du over 4. Okay? Now, from here, there is a rule that says that any constants, like regular numbers, I can pull to the front of an integral. Do you remember that?
Yes.
Yeah, so if this is a 4 on the inside of the integral, I'm going to just take that constant and I'm going to pull it outside. So instead of a 4 under the du, now it's a 4th in the front, integral cosine u du. So my 4th moves out, my du stays where it's at, my cosine u stays where it's at. What is the integral of cosine u? Sine u. Still with the 4th in the front, plus c. And then in my last step, I'm going to switch it back to x, and that's my answer. So if I had a 4th sine u, that's really a 4th sine what? 4x. Got it? Okay, now, real quick, I don't want you to write this down. I just want you to think about it. What would the derivative of a 4th sine 4x be? What would I get? Okay, think about it. What's the derivative of sine? Cosine. Cosine 4x times what if I do chain rule? 4, but then if I have a 4th in the front, what happens?
Cancel.
And what would I get? What I started with. So you're undoing a chain rule, but you can check it by taking the derivative and making sure that it looks the same. Okay? So that's only to check your work though. Okay, we're going to do 2 more, then we'll write out very specific steps for you to follow. Ready? Okay, next one, number 2. We're going to do the integral of sine x squared 6x dx. Okay, so first question, if you were doing chain rule, your u is always inside another function. So what should I pick? X squared, good. So my u is x squared. Now I need to find du dx, which is the derivative of that. 2x. Right? Then from there, I take my dx, I move it over to the other side. And now I need to solve for dx, which means I'm going to have to divide by 2x. So what is dx going to equal? du over 2x. Perfect. Circle this and this. These are my substitutions. So my sine of x squared is now a sine what? X squared is really just a u. Leave the 6x alone, that's not anything. And then dx is going to turn into what? What's dx now? du over 2x. Okay, from there, there is a rule that says that I can bring any constants to the front. What are my 2 constants here? Now, 6 and 2 are constants. X's don't count, right? So my 6 and my 2 can come to the front. But what is 6 divided by 2?
3.
So I'm going to pull a 3 to the front. Integral sine u. And then what do you notice is going to happen if I have one x on top and one x on bottom? Cancel out. They're gone. So this x and this x cancel out together. Du. 3 move to the front. How do we get the 3? 6 divided by 2. Okay, from there, what's the integral of sine u? -3 cosine u, right? Because we're doing the antiderivative. Plus c. Last step. Replace u back with x squared. Very good. So I'd get -3 cosine x squared plus c. So remember that when you do the integral with a dx, they go away together. It's the same with a u. This is telling you what your variable is. So in this case, my variable is a u. Then when I take the integral, the du goes away with the integral. Now, just for practice, what would the derivative of this have been? What's the derivative of negative cosine? So snow cone,
Sine.
regular sine. Okay, then x squared, but then what's the derivative of x squared? 2x, but then what did I have in the front? Was 3 times 2x, 6x, and then sine x squared. Is that what I had when I started? Then you know you did it right. Make sense? Yeah. Okay, one more, then we're going to write out your steps. Okay, the next one, number 3, is going to be the integral of 12, 1 minus 3x squared dx. Now, when I choose my u, you should notice that I'm always trying to pick a function inside another function. So I don't have any trig here, but this is my middle, right here. So for my u, I'm going to pick 1 minus 3x. Everybody good with that? You don't take the squared because that's what your u is inside. It has to be inside another function. So I don't want to take the squared because that's my outside function. Okay, so what is du dx? What's the derivative of 1 minus 3x? -3, then what? Dx moves up. And then I have to solve for dx, so my -3 moves down. So now I have dx equals du divided by -3. Circle, circle. Those are my substitutes that I'm going to use. Okay? Let's rewrite our integral. So integral of 12, that's just kind of chilling there. Okay, what is this in the middle called? 1 minus 3x. 1 minus 3x is now a u, and it was squared. And my dx is now a du divided by negative 3. Du divided by negative 3. Now, I can pull the 12 and the negative 3 where, since they're just numbers? Okay, to the outside. It'd be a negative 4 on the outside. And now that I just have u squared, sorry, wrong number, du, I can do power rule on that. So, what's the antiderivative of u squared? What do? I add 1, so I get what? U to the 3, and then a third. What did I already have in the front? Negative 4, which means what's that fraction in the front? Negative 4 thirds. U switches back to a 1 minus 3x cubed plus c. Make sense? When you take the antiderivative, the integral and the du go away together. So I have the integral until I've done the power rule, and then that's when it goes away. How do you feel about that? Eh? Okay, so we're going to write out the steps, and then I'm going to give you one to try. Okay? Can I pull this? Good? Okay, so put steps. Okay, steps for you, sub number 1, you're going to choose u equal to x stuff inside another function. Okay, you want the most inside x stuff that you can find. Okay, after I choose my u, step number 2, I'm going to find du dx, which is the derivative of u with respect to x. So I'm going to find du dx, which is the derivative of u with respect to x. Step number 3, I'm going to solve for dx equals. And it should have a du with more x stuff. So your dx should have a du in it, and then just more x crap from your integral. Okay? After you do that, 3 more steps left. Number 4, you are going to rewrite integral in terms of u. Now, in this step, what am I allowed to pull outside of the integral? What type of thing? Constants only. So I'm going to put a little star here. In this step, when you rewrite it, if you have any x's, they have to cancel out. You cannot keep going if your x's don't cancel out. So I'm going to put here, all extra x's should cancel in this step. So if I had an extra 6x left over, the 6 can stay, but the x better cancel out. Okay, then after you do that, you're going to do the antiderivative. And then I'm going to put, don't forget the plus c. And then in your last step, you're going to rewrite it with your x stuff back in. Rewrite solution in terms of x. Okay. Okay, which leads us to our 4th example. You ready? It's going to be x cubed plus 2 5x squared dx. Okay, so I'll bring you a candy. Give it a shot. Pick your u. Take your derivative. Solve it for dx. Now, before you start, let's make sure we all pick the right u. What u should you be picking? X cubed plus 2, because it's where? It's in the middle. That's how you know. So make sure for your u, you should be picking this guy in the middle here. And you can ask somebody for help if you need it. You can do it. Any candy?
I was thinking anti-derivative, so I was like, 1/4 instead of 4.
Jeremy, you want one?
Oh my, this.
You? Yes. Have you taken it? Get it together, boy. Okay, now what should happen to your x squared when you rewrite? It should cancel. If it doesn't, that's bad. Okay. You want one?
3x squared.
You want one? Yeah.
No, because you have to, you're dividing the x.
No, this is a
You don't cancel them out if you use the constant.
Did you forget the 1/5? Oh no, wait, yeah, the 5's cancel out. Yeah, that's right. Let's see. Good job. Alright, let's see how you did. Not yet? Not yet?
Is the constant 5/2?
No, it should be 1/5. Let me see. Okay, your derivative of this, the 2 should go away. Because remember when you take the derivative of a constant, it zeroes out. Okay, so your du should have been 3x squared. And then I'm just going to move my dx over now. Okay, you can write it at the bottom and move it if you want. Then when I solve for dx, it's equal to what?
Du over 3x squared.
Okay, du over 3x squared. Then I come over here. This is changing to a u. This is changing to a du over 3x squared. Good with that? So I have integral of u to the 4th, 5x squared, du over 3x squared. And then what happens with my x squareds? Cancel out. What's my constant moving to the front? 5/3 is going to come out here. So I have a 5/3 integral u to the 4th du. And then I can normal power rule that. Add 1, it's u to the 5th. Divide by 5, it's a 1/5, but I already had a 5/3. What's going to happen with my 5s? So now it's just a 1/3 x cubed plus 2 to the 5th plus c. So remember, for the antiderivative, you add 1 to your exponent. So if it was a 4th, I add 1, I get a 5th. Then I divide by 5 here. That's where the 1/5 came from. Okay, I'm going to give you another one to try. Work together. Okay, integral of, we'll do 20 over 5x plus 1 dx. Okay, ask me for help if you need it. I love to help. when you do the integral, remember the du goes away. Because you did the power of 1. So you added 1 and then divided. So when this goes away, this goes away. Because they're kind of like a dx. It's like an integral dx. Yes. Okay, very good. The u should be just this part right here. 5x plus 1. Okay, because where is that? That's inside the fraction. Okay? So give it a shot. So 5x plus 1, that's going to be your u. We're doing number 5 right here. On what to pick?
Well, where's the problem?
Oh, yeah. Right there. So it's 20 over 5x plus 1. 20 over 5x plus 1. Need help? Anybody got it? Yeah. Yes, good. Okay, if you didn't hear what she said, your answer should have an ln in it. Because you end up with your u as on the bottom, that's a 1 over u. The integral of that is du. Yeah, so what's 20 divided by 5? 4 in the front. Now the plus 1 should be here. Remember when you take a derivative?
Oh, yeah.
So then at that point, now it's a 1 over u du. And 1 over u, what's the integral?
Is it more LNU?
Uh-huh. Okay, so look guys, your du should be 5 only dx. Some of y'all are keeping the plus 1. What's the derivative of 5x? 5. What's the derivative of 1? Nothing. Okay, then that means my dx is a du over 5. And then from there, I'm going to rewrite. So this is the integral of 20 over u du over 5. What's 20 divided by 5? And that's going to move to the front. So I have 4 integral, and then it's not just a u, it's a 1 over u, right? Because my u is on the bottom, and I don't rewrite this as a power, that's a special. Integral of 1 over u is ln u. Technically, don't forget your absolute value bars, then switch it back to a 5x plus 1 in the middle. Got it? Okay, we have 2 more left to get through. And almost 10 minutes. We can do it. Okay, next one.
6, I know.
Oh, I always think that it's 59. It's 51. Okay, we can at least get through one more.
You tried it.
I did. 7 over...
That's bad that calculus keeps
Literally all the time. This is my life. So. Half of y'all's worksheets are like A, B, C, B, F, G. Like, lettered totally wrong. Okay, what do you guess you should pick? Okay, 2x plus 1 from the middle. That's my u. Do I include the 4th? No, too much. You only want the middle. So 2x plus 1 goes here. Give you a second to get ahead of me. Okay, what's the derivative of 2x plus 1? 2 what? 2 dx, right? So dx is du over 2. Do your integral. 7 stays on top, u to the 4th, du over 2. What do I pull out to the front? 7 over 2 comes to the front. And now I have 7 over 2 integral 1 over u to the 4th. can I or can I not ln that? Cannot. What do? Negative 4. Remember, it's a rewrite. This is really integral u to the minus 4. You have to do a rewrite. The only ln is 1 over u. Not 1 over u squared, 1 over u cubed, 1 over u to the 100th. Everything else you power roll except 1 over u. So add 1. Okay, negative 3. Then divide by negative 3. So I'd have 7 halves times 1 over negative 3. Times the tops together, that's a 7. Times the bottoms together, it's a negative 6. And then it'd be 2x plus 1 to the minus 3 plus c. Now, nobody would leave it like that on the AP test. Where would they put this term if its exponent is negative? On the bottom. So that'd be negative 7 over 6 2x plus 1 cubed plus c. Okay? But this is totally good enough for the FRQ, but if it was multiple choice, they'd do that to it. Okay? Alright, we will do more of these notes tomorrow. Look over your homework, try to find a couple hard ones where maybe you don't know what U is, so that we have a couple examples to go over tomorrow. Okay? You have 3 minutes till the bell.